Okay, good morning. So today we're going to talk about applications of rational expressions. So this is the word problem part, right? So your book, number 50, has a very nice problem to introduce you to the ideas of how to set these up. And we're going to walk through that first, and then we're going to do an example. So a car travels 4 miles per hour slower than a motorcycle, and then we're going to write all these things down. They're not asking us to solve anything today, this problem. They are just asking us to set things up, all right? So write an expression for the speed of the car. Okay. Well, they said x is the speed of the motorcycle. So x is the speed of the motorcycle, miles per hour. Speed of the car travels 4 miles per hour slower than the motorcycle. So whatever the speed of the motorcycle is, the speed of the car is a little bit slower. Again, I give us a little unit there, so we have miles per hour. Okay. Part B, write an expression for the time it takes the motorcycle to travel 50 miles. So we're going to start off with our favorite model, d equals rt. Okay. We're going to solve this expression for t, so we're just going to slide the r underneath that d there as a division sign. So t is equal to d over r. We're not done yet. They want the specific for this particular problem. Okay. So in this problem, it says find the time it takes for the motorcycle to travel 50 miles, and its speed, they said the speed is going to be x. All right. Part C, so we got back in the frame. So part C, write an expression for the time it takes the car to travel 145 miles. All right. So the car, I put a little T car under here, although you don't have to do that. The book will not let you put this in. It will yell at you a bit. T is equal to the distance, and it's at 145 miles over the speed. Okay, so that's 145 over the speed of the car, x minus 4. And that's all they wanted to do with this problem. Okay, and that sets things up very nicely so that if they ask any further questions, we will have some expressions. We'll have things with x's and t's in it we'll be able to solve. So everything will be ready to go. Right? So case in point, all right, we are going to go ahead and solve number 54 for us. Okay, we're going to deal with number 54. So it says Kathy can run 3 miles to the beach in the same amount of time. Dennis can ride his bike 7 miles to work. Kathy runs 8 miles per hour slower than Dennis. Find their speeds. Okay, well, let's use the original problem, the problem we just did, as a model. So let's let x equal Dennis's speed. Dennis. And then it says, well, Kathy runs 8 miles per hour slower than Dennis. So x minus 8 must be Kathy's speed. All right. Now, what we're going to do is see this in the same amount of time. This is telling me that even though no fractions, they're going to have us deal with time is equal to d over r. Okay, so that's pretty much in the same amount of time. That's telling you should probably solve things in terms of t, because that's the variable we're going to be dealing with, or at least that's the key to unlocking how a lot of this works. Okay, so let's go ahead and write let's write an expression for the time it takes Dennis to ride the bike to work. Okay, so the time for Dennis to get to work. Okay, so T for Dennis is equal to D over R. It says he rides his bike 7 miles to work, so that's going to be 7 divided by, what's Dennis's speed? Oh, that was X. Okay, again, we can put a little miles per hour here, put a little miles per hour here so we know what we're talking about. All right, and then it says Kathy runs 8 miles per hour slower than a bike, find her speeds. So we're going to be setting this up. Okay, it takes the same amount of time for this to happen. So this is the situation here for Dennis. Okay, how about time for Kathy to run to the beach? She runs 3 miles to the beach, and her speed is 8, or x minus 8 miles per hour slower. This is for Kathy. All right, and then they said, well, it's in the same amount of time. So this t and this t, those should be the same thing. we can equate these. We can say, well, that's 7 minus x is equal to 3 over x minus 8. Right? So that's how we've equated these things. All right, let's move this up a little bit. Let's see what's going on. All right, now all we have to do is solve this rational equation rather. And we could cross multiply, that would be fine. I'm going to go ahead and continue the way we've been doing it for the harder, the more difficult rational expressions, or rational equations rather, and clear the fractions. So the x over the x here, as this term visits the left-hand side, the x over x cancels, so we end up with a 7 and an x minus 8 here. And then over on the right-hand side, when this common denominator visits this side, the x minus 8's cancel, and we end up with a 3x. And now we just have to solve this. So we have 7x minus 56 is equal to 3x. We're going to go ahead and get all the x's on the left-hand side. Okay, 7x minus 3x, right? We end up with 4x minus 56 is equal to 0. 4x is equal to 56. We're adding 56 to both sides. We're sliding this thing over. And then we're going to go ahead and divide both sides by 4. So we have 4x over 4 is equal to 56 over 4. And x is going to be 14, if I'm not mistaken, right? 4 times 14 is going to be 40 plus 60, that's 56. Okay, and then since I know what my speed is, see, all the way back at the beginning, we said x is Dennis's speed, miles per hour. I know this is 14 miles per hour. I figured out their speed. Okay, so this is for Dennis to ride his bike. And then Kathy, hers is x minus 8, or 14 minus 8, better known as 6. And this is Kathy's running speed. All right, and I think that solves the problem for us, right? Find their speeds. We're done. All right, fantastic. Let me do one more for us. All right, that way we can make sure that we have everything. Okay. We have actually, if you want to do be the astute student, be the proactive student, what you would do is pause the video here and go ahead and work this thing out and then see whether or not we're getting the same answers here. All right. So we have a weekend athlete, rides a bike path 20 miles to a waterfall and then relaxes a bit. He finds he is only able to travel 12 miles back in the same amount of time it takes him to travel to the waterfall. If his average speed going to the waterfall is 4 miles per hour faster than a return trip, what is his average speed going to the waterfall? Well, let's let x equal speed of return trip. All right, that didn't have a modifier on it. X plus 4, right, is the speed to waterfall. Okay, so let's go ahead and let's write an expression for the time it takes for him to get back from the waterfall. Okay, so this is time of return trip. T equals RT, so T must be D over R. So we're going to say that for this particular case, right, on the return back, he's going to say T is equal to 12 over how fast was the trip. The X was the speed of the return trip. Okay, so the important thing is, do you see the parallel between how we're setting up this problem with what that first problem gave us? All right, and then how about time of forward trip? Okay, time of to waterfall. Okay, so again, we're going to have T is equal to D over R. T is equal to, well, the distance there, right? The distance there was the 20 miles to the waterfall, all right? And it was X plus 4 because he was a little bit faster doing that, right? And then we have to figure out what the speed is to the waterfall. So I'm going to go ahead and we have all the information that we needed from the problem kind of stored up here. They told us, this is going to remind us, okay, that it took the same amount of time to travel the waterfall. So the 12 miles back was the same time as the trip to the waterfall. Okay, so just to remind us that these t's are going to be the same. So we're going to have 12 over x is equal to 20 over x plus 4. And again, we're going to multiply by common denominators. All right, so we can clear our fractions because nobody likes dealing with the fractions. When this common denominator visits the left-hand side, right, the x's cancel, so we end up with a 12 and an x plus 4. That's equal to 20. And then on the 20, the x plus 4's cancel, so we have a 20x, right? And now we just have to solve this algebraic equation. So we have a 12x, 4 times 12, right? That's 48, is equal to 20x. Let's go ahead and solve for the x's. So we're going to get all the x's on one side. Normally, people put all of this on the left-hand side. It doesn't really matter. All right, so now we'll go ahead and change this around. And then 48, and my old nemesis, 6 times 8 is 48. Go ahead and divide. X is equal to 6. So he travels, right, 6 miles per hour. That's the speed of the trip. I should have written this down as a miles per hour when I declared my variable here. Okay, so we have a 6 miles per hour for the return trip. Okay, and then to the time forward, okay, x plus 4 is equal to 6 plus 4 is equal to 10 miles per hour on the way to the waterfall. Okay, so that tells us everything we wanted to know about this problem. That's all they asked for, right? What is the average speed going to the waterfall? 10 miles per hour. Okay, so time for you guys to try a couple. Please get a start on that homework and practice a few. It doesn't help you to watch me do it so much. That's not everything. You have to do it yourself too. All right, thank you.